Eigenvalue and eigenvector of the matrix minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So we have three steps, right? So step number 1, to find characteristic equation. So we know that characteristic equation for 3 by 3 is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is sum of the main diagonal elements. A diagonal elements minus 1, 2, 0, right? So minus 2 plus 1 plus 0, so which is equal to minus 1. S2 is sum of the minor of the main diagonal elements. Minor of minus 2 is omit the column and rows. So we get 1 minus 6 minus 2, 0. Then minor of A2, 2, right? Minor sum of the minor of the main diagonal elements. Diagonal elements minus 2, 1, 0. So minor of minus 2 is, then minor of 1 is, what is the minor of 1? Minus 2 minus 3 minus 1, 0. Then minor of 0 is minus 2, 2, 2, 1. So determine expansion 1 into 0, 0 minus 2 into minus 6 is plus 12. Right? 1 into 0, 0 minus 6 minus 2 is plus 12 plus minus 2 into 0, 0 minus 1 into minus 3 plus 3. Minus 1 into 2 minus 2 minus 4. Alright? Just determine expansion. Minus 1 into 2, 2 minus 2 minus 2 into 2, 4. So minus 12 minus 3 minus 6. How much? Minus 15 minus 6 minus 21. And then find S3. What is S3? S3 is determinant of A. S3 is determinant of A. What is determinant? What is given matrix A? Minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So determinant expansion. So first A1, 1, minus 2. Determinant expansion is 1 into 0, 0 minus 2 into minus 6 plus 12. Then A2, 2 minus 2 into 0, 0 minus 1 into minus 6 plus 6 minus 3 into omit that row and omit that column, right? So minus 2 into minus 2 minus 4 minus 1 into minus 1 so plus 1, right? Again check one more time. Minus 2, 1 into 0, 0 minus 6 into 2, 12 minus 2, 2 into 0, 0 minus 6, right? Then minus 3, we get 2 into minus 2 minus 4 minus 1 into minus 1 so plus 1, right? So minus 12 into minus 2 is minus into minus plus 24. Minus 2 into minus 6 is plus 12. And then minus 4 plus 1 is minus 3. Minus 3 into minus 3, so plus 9. How much? 9, 11, how much? 24, 26, 45. So substitute the value of S1, S2 and S3 in equation 1. Substitute the value of S1, S2 and S3 in equation 1. We get the characteristic equation. What is the characteristic equation? Lambda cube minus S1 lambda square. What is S1? Minus 1. So plus lambda square. And then S2. What is S2? Minus 21. So minus 21 lambda. And S3 is minus S3. So minus 45 equal to 0. Which is the Rydberg characteristic equation? Which is the Rydberg characteristic equation? Step number 2, find eigenvalues. So how to find eigenvalues? To solve the characteristic equation, we get the characteristic roots are eigenvalues. So solve the characteristic equation. So solve the characteristic equation by which method? Synthetic division. By synthetic division. So write down the coefficients of lambda cube, lambda square, lambda and constant in characteristic equation. What is lambda cube coefficient? 1. Lambda square coefficient? 1. Lambda coefficient minus 21 and constant is minus 45. So by trial and error method, start with plus 1, minus 1, plus 2, minus 2 and so on, we get, right? Suppose if you put lambda equal to minus 3. What is 1 into minus 3? Minus 3. 1 minus 3 is minus 2. Minus 3 into minus 2 plus 6. So how much? 15. Minus 15. So minus 15 into minus 3 is plus 45. So So do one more time. Cubic equation, we have to get 3 values, right? So again we'll start with minus 3. So we get 1 into minus 3, minus 3, minus 3, minus 2, minus 5, plus 15, we can see. So therefore, the eigenvalues are, what are the values? Minus 3, minus 3. Third eigenvalue here, minus 5, this lambda coefficient, this constant. So lambda minus 5 equal to 0, therefore lambda equal to 5. So write it in opposite sign. Here minus 5, therefore I am writing here plus 5. Here minus 3 repeated twice, therefore I am writing here repeated eigenvalues. So in the previous one, we have discussed non-repeated eigenvalue 1, 2, 3. Here eigenvalues are 5, minus 3, minus 3. So minus 3 repeated twice, so therefore I am writing here repeated eigenvalue. Right. And then what is the next step? Third step is to find eigenvectors. What is the eigenvector equation? A minus lambda I into x equal to 0. Where A is the given matrix, lambda is the eigenvalue, I is the unit matrix, x is the non-zero column vector. Substitute the values. Substitute the values. What is A? A is the given matrix. A matrix is minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. A matrix, right? A minus lambda I. Lambda into I is the unit matrix for 3 by 3. Into x is the non-zero column vector for 3 by 3. x1, x2, x3 equal to 0. Right? So we get, so first multiply with lambda, we get lambda, 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 and then subtraction of 2 matrices, we get minus 2 minus lambda, 2 minus 3, 2, 1 minus lambda, minus 6, minus 1, minus 2, minus lambda, into x1, x2, x3 equal to 0. So let it be equation 2. So first case is, what are the eigenvalues? Lambda equal to minus 3, 5. So first we do for repeated, non-repeated eigenvalue. That is case 1, lambda equal to 5. Substitute the value of lambda in equation 2. We get minus 2, minus 5, minus 7, 2, minus 3, 2, 1 minus 5 minus 4 minus 6 minus 1 minus 2 minus 5 into x1 x2 x3 equal to 0. So write down the equation. Minus 7x1, write it in equation. Minus 7x1 plus 2x2 minus 3x3 equal to 0. Second equation, 2x1 minus 4x2 minus 6x3 equal to 0. Third equation, minus x1 minus 2x2 minus 5x3 equal to 0. So equation, all the three equations are different. So consider any two and solve by cross multiplication rule, right? So equation 2, throw divided by 2, we get 1 time, this 2 time, this 3 time, right? For simplification. So in third equation, throw multiplied by minus, we get plus, plus, plus. So consider equation 2 and 3 and solve by cross multiplication rule, right? Solve 2 and 3 and solve by cross multiplication rule. So solve equation 2 and 3 by cross multiplication rule. So cross multiplication rule is start with x2, end with x2. So equation 2 and 3. What is the equation 2 coefficient? Equation 2 x2 coefficient is minus 2, x3 coefficient is minus 3, x1 coefficient is 1 and x2 coefficient is minus 2. In equation 3, what is the coefficients? 2, 5. Equation 2 coefficient, x2 coefficient is 2, x3 coefficient is 5, x1 coefficient is 1, x2 coefficient is 2. So x1 value is minus 2 into 5 is minus 10 minus 2 into minus 3 is minus 6, so plus 6. x2 value is minus 1 into 3 minus 3 minus 1 into 5 is 5. x3 1 into 2 2 minus 1 into minus 2 minus 2, so plus 2. So simplify this, we get minus 4 minus 8 then 4, right? So here throw first value should be positive, right? So throw divided by minus, we get plus, plus, minus, then 4 is common, so throw divided by 4 we get, so throw divided by minus 4 we get 1 2 minus 1, right? So therefore x1 value is, first eigenvector value is 1 2 minus 1. Then case 2. What is case 2? Minus 3 repeated twice, right? Case 2. Lambda equal to minus 3. Minus 3 repeated twice. So when lambda equal to minus 3, substitute the value of lambda equal to minus 3 in equation 2. Minus 3 plus 3, sorry, minus 2 plus 3 is 1, 2 minus 3, 2, 1 minus of minus 3 is 4 minus 6 minus 1 minus 2 plus 3 into x1, x2, x3 equal to 0. Right? Listen here. In equation 2, so I am writing an equation x1 plus 2x2 minus 3x3 equal to 0. Second equation 2x1 plus 4x2 minus 6x3 equal to 0. Third equation minus x1 minus 2x2 plus 3x3 equal to 0. Equation 2, throw divided by 2, we get x1 plus 2x2 minus 3x3, right? In equation 3, throw multiplied by minus, we get x1 plus x2 minus 3x3 equal to 0. So all the three equations are same. So consider the first equation, right? All the three equations are same. So we cannot apply cross multiplication rule here. All the three equations are same. So we cannot apply cross multiplication rule here. Underline the word same. So what is the first equation? Consider the equation x1 plus 2x2 minus 3x3 equal to 0. Here minus 3 repeated twice, right? Repeated eigenvalue, right? So for this time we have to substitute any one of the variables 0, find out the eigenvector, right? So if we put x2 equal to 0, if we put x2 equal to 0, we get the equation reduces to x1 minus 3x3 equal to 0. So x1 equal to 3x3. So x1 divided by 3. Just cross. Just cross multiply, we get this equation, right? 1 into x1, x1, 3 into x3. So x1 value 3, x3 value 1, x2 value 0. This is the second eigenvector x2. So third eigenvector, to find the third eigenvector, put any one of the variables 0. We already substitute x2 0. So put x3 0 or x1 0. Any one. So put x3 equal to 0. So x3 equal to 0. The equation reduces to x1 plus 2x2 equal to 0. So x1 equal to minus 2x2. So therefore x1 divided by 2, x2 divided by minus 1. Right? Just cross multiply, we get this equation, right? Minus x1 2x2. Same equation, right? So therefore, the third eigenvector is, what is x1 value? 2, x2 value minus 1, x3 value 0. That's all. So to find eigenvalues and eigenvector for repeated root. So one important note. So one important note for non-symmetric matrix. So in the previous sum, 1 and 2 are non-symmetric. Non-symmetric means rows and columns are not unequal, not equal. Note, non-symmetric matrix. So first, suppose we have an eigenvalues like this, 3, 2, 2, right? 2 repeated twice, so repeated eigenvalue. Equations equal, substitute x2 equal to 0, x3 equal to 0. So if you put x2 0, we get the second eigenvector. x3 0, we get the third eigenvector. Lambda equal to 3, we get the first eigenvector. Suppose equations are distinct. Equations are distinct. So take any two equations for solving. Take any two equations for solving. So x2 equal to x3. So if equations are different, solved by cross multiplication rule, we get one eigenvector. If equations are same, substitute any one of the variable x2 0 or x3 0, we get the second and third eigenvector. Same. eigenvalues are equal, 2 repeated twice. Suppose equations are equal, put x2 0, we get one second eigenvector, x3 0, we get the third eigenvector. Suppose equations are distinct, consider any two equations solved by cross multiplication rule, we get one eigenvector, that is x2 equal to x3. Similarly, lambda equal to minus 1, minus 1, minus 1. Similarly, we have two cases. So equations equal, put x1 equal to 0, we get first eigenvector x1, x2 equal to 0, we get the second eigenvector x2, x3 equal to 0, we get the third eigenvector x3. If equations are distinct, solve by cross multiplication rule, x1 equal to x2 equal to x3. There is an important rule for non-symmetric matrix. If equations are equal, put any one of the variables 0, find the eigenvectors. If equations are different, solve by cross multiplication rule. If three eigenvalues are equal, equations are same, put x1 0, we get first eigenvector, x2 0, we get the second eigenvector, x3 0, we get the third eigenvector. Equations are distinct, solve by cross multiplication rule. That is x1 equal to x2 equal to x3. Thank you.